Okay, so in this video, it's going to be a recap of everything we've learned, and it's 20 points for watching this video. Make sure you also take notes down too, because this is going to really help you with your review and then also for your test. So read this first problem about Samari messing with Miss Rowell's pencil sharpener. We know it's going to be on the third day, and we also know that he spun the sharpener 5 times. So that's where we get 3 and 5 from in our table. Then we know every day he spins it 7 more times. So that's where this plus 7 comes into play for our table. So when we write our recursive equation, it's going to go f of x equals f of x minus 1 plus 7, semicolon, f of 3 equals 5. Okay, all the colors match. So if you want to use colored pencils, please do. I really, 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 really recommend it. The explicit equation goes f of x equals 5, our start number, plus our common difference of 7, times x minus 3, because we do the opposite of the minus 3 there, okay? So we do the opposite here. All right, next up, we are going to figure out how many spins are on the 9th day. So that's where we use the explicit equation here. It's always good to use the explicit equation. And so we get f of 9 equals 5 plus 7 times 9 minus 3. And that stuff I have underlined in orange, please type in your calculator and tell me what you get. So hopefully we got 47. So f of 9 equals 47. All right, go ahead and read this next problem, answer some questions about what we know. All right, so we know in the 17th minute of class, Mason already sent 29 text messages. We also know that every 3 minutes that passes, he sends 5 more. Okay, so my table starts with 17 and 29 because that's our start numbers, right? That's what we know Mason has already done. And then that green plus 3 and that green plus 5, that's what he's doing every 3 minutes. He sends 5 more. So this is a common difference, but it's going to be a common difference fraction. So when we write a recursive, we're going to have f of x equals f of x minus 1 plus 5 over 3 given f of 17 equals 29. So again, that fraction is because we added on both sides of the equation. So the numbers for your f of x go on the top, which is purple, and then the green is the x side, so that goes on the bottom. So our explicit equation is going to go f of x equals 29 plus 5 over 3 times the quantity x minus 17, because again, we want to do the opposite of our start number next to our variable in the explicit. We're going to use that explicit equation to figure out how many messages he sent on the 32nd minute, which means we're going to replace all those x's with 32s. So tell me what I have underlined in orange here. Type it into your calculator. Tell me what you get. So hopefully you got 54, okay? All right, so let's look at the next word problem, and I want you to read through it and then answer some questions for me. Okay, so we know that each month she wants to increase her payment by 15%. So that means we're using percent, so we have to change that to a decimal, which is what we did right here. And since it's an increased percent, we do 1 plus the percent, which gives me 1 plus 0.15, and that means we get 1.15. So that is our common ratio. All right, what else we know? Sorry, that was a lot. But we also know that on the first month, she's paid $200. Okay, so we have f of x equals f of x minus 1 times 1.15. And again, percents are always common ratios. Always. That means you're always going to multiply with those percents. And then f of 1 equals 200. So now for the explicit, f of x equals 200 times 1.15, exponent x minus 1, and it's an exponent because we are multiplying this time. Then to figure out how much she's going to pay on the 6th month, we have to use that explicit equation again, and replace all those x's with 6's. When I type that stuff, 200 times 1.15 to the exponent 6 minus x, tell me what you get. We get 402.27. I know there's a lot more decimals, but this is all I really needed because we're talking about money. You can't have more than 2 decimal places for money. All right, so in number 4, we have a table. But what do you notice about the table? Okay, so hopefully you said you noticed there's going to be more and more decimals. So that means that you have to do the second number divided by the first number to give you your common ratio. So we have to do 8 divided by 10, and that gives me 0.8. Now, this is a common ratio, so we're multiplying. So when I write this out, and remember, before I continue here, this is my start number, that's 10, and that 1 with it is our start time. So we have f of x equals f of x minus 1 times 0.8, given f of 1 equals 10. Explicit goes f of x equals 10 times 0.8 to the exponent x minus 1. All right, so when we figure out the seventh term, again, we're using that explicit, replacing all the x's with 7s. And tell me what you get in that stuff underlined in orange right there. All right, hopefully you got this really long decimal that I'm not going to say. So number 5 here, we're looking at a table, but notice it goes 20, 16.5, 13, 9.5. So in this one, we have a pattern decimal, right? Because we go decimal, no decimal, decimal. So that probably means we're using a common difference. So that means we have to do the second number minus the first number. So we do 16.5 minus 20.5, and that gives us minus 3.5. So minusing 3.5 is what we're doing as we go down the table. So we have f of x equals f of x minus 1 minus 3.5 given f of negative 2 equals 20. And again, that negative 2 is my first x value, and that 20 is my first f of x value. So you always want to write those out, especially when tables they're just given to you. That's like really nice. Okay. Then we write our explicit. So f of x equals 20 minus 3.5 times x plus 2. And again, we always want to do the opposite of our start time. Always, always, always. For the explicit only, though. The recursive, you just copy and paste. Explicit is the only time you do the opposite. All right. So now we want to figure out the seventh term. So again, we're going to use that explicit equation. We're going to replace all those x's with the number 7. And so what I want you to do is take that stuff I have underlined in orange right here, and I want you to type that into your calculator, and I want you to tell me what you get. So hopefully you got a negative 11.5. So in this next one here, we have a table, but we're minusing 2 on the left side and adding by 3 on the right side. So this is a common difference, but it's going to be a fraction common difference. And once more, 5 is my boyfriend. We have 5 for our start number and 5 again for our start time. When I drop this down, I write a recursive of f of x equals f of x minus 1 minus 3 over 2. So we have to use that minus sign. That's part of our x. That's going to mean that we're subtracting 3/2, okay? So just be careful of something like that. All right, then we have f of 5 equals 5. So when I drop this down more, we get f of x equals 5 minus 3 over 2 times the quantity x minus 5. And again, we do the opposite of our red start time here. That's the red 5. So again, everything's always color coordinated. So again, this is why I'm asking you to use colored pencils in your notes. It's like such a good idea. So when you like take a quiz or take a test, you understand where what came from where. So we're trying to find the negative 7th term this time. So we're replacing all of our x's with a negative 7. So this gives me 5 minus 3/2 times the quantity negative 7 minus 5. So type this into your calculator. Be careful. That orange negative 7 there, that's a negative symbol. So that's the button that's next to your enter in your calculator. So we should have gotten 23. So in this next one, we have a table. So we're taking these dots and we're plugging them into our table. And then the color of the dots match the color that's on the table. See how I do this? And this time we have minusing by 3 in purple on the right side and adding by 2 on the left side. So once again, this is going to be a fraction common difference. And we have a minus, so that means we're going to have a subtracting common difference. So when I drop this down, f of x equals f of x minus 1 minus 3 over 2. And that's why the minus is in purple, because that came from that purple minus 3 from our table right over here. So that's where that came from, okay? F of negative 2 equals 5. Then we have our explicit. So explicit is f of x equals the blue 5 minus 3 over 2, parentheses x plus 2. And then what's the 6th term? So again, we replace all our x's with 6's. using the explicit. It's always best to use the explicit. The explicit helps you find literally any number you want. The recursive only helps you find like the next number. So when I type this into my calculator, I get f of x equals -7. Again, your table will be fixed. Mine was not, but I'm sorry, your graph will be fixed. My graph was not. So when I take these dots and put them in my table, again, you read graphs left to right. My colors match the dots, so the red dot, the blue dot, the green dot, the red numbers, the blue numbers, the green numbers. And I'm multiplying by 3 as I go down my table. So when I write my recursive equation, it's going to go f of x equals f of x minus 1 times 3, given f of 1 equals 2. And then the explicit, you always start with your start number, so your first f of x. So f of x equals 2, what we're doing down the table, times 3, to the exponent x minus 1, because this time we'd be multiplying. So we find the sixth term and replace all the x's with 6's. So tell me what you get. F of x equals 486. Big numbers. All right. Now we have like an image thing. So look, this says step 2 with 3 hearts. So when I fill out my table, step 2, 3 hearts. Step 3 has 9 hearts. Step 4 has 15 hearts. So that's how I fill my table, which means I'm adding by 6 as we go down our table. I also need to note that our start time is this 2 here that we started with, and the 3 is our start number because that's the number of hearts we started with. So recursive f of x equals f of x minus 1 plus 6, given f of 2 equals 3. Again, the red does not change in the recursive. It changes when we write our explicit. So f of x equals 3 plus 6 times x minus 2. That's where it changes. So same z's, but this time they're opposite in the explicit, okay? So we find the 10th term, which means we replace all the x's with 10. So when I do that, I have 3 plus 6 times the quantity 10 minus 2. Type that in the calculator, tell me what you get. We should have gotten 51. All right, this one's fun. So this time we have f of n equals f of n minus 1 minus 6, given f of -2 equals 11. So this is my start time, 11 is my start number, and minusing 6 is the math I do down my table. So look at my table. See how it's always good to use a table. It's always like the best way to make sure you have everything written down correctly. So we have -2 and 11. We're minusing by 6. So when I write my explicit equation, and if you need to use a table, great. And if you didn't, and you knew how to do it from the recursive to write the explicit, even better. We get 11, our start number. We're minusing by 6 as we go down. And then in red, we have n plus 2, because remember, we want to do the opposite of our first x. So when we find our fifth term, again, we're going to use the explicit equation. We're replacing all of our n's with the number 5. And then I want you to type this in your calculator. Tell me what you get. -31. Okay, this time we are given an explicit equation. So this is my start number, this 5. Again, 5 is my boyfriend apparently. And then our start time is 2, not the -2, because remember, we do opposites in the explicit. And then this 2 timesing 2 is our math that we're doing as we go down our table. So my table is 2 and 5, and then we're multiplying by 2 as we go down. So my recursive equation is going to be f of n equals f of n minus 1 times 2, given f of 2 equals 5. Because again, remember, when you write your recursive, your start time doesn't change. Start time, which is the stuff I've been writing in red, only changes when you write it in the explicit. So this time it's asking us what is the fifth term. So this time we're actually going to use the recursive equation just to figure out the next one, because we already have 2, 3, 4. So the next one would be 5. So what would be 5's number partner? It's going to be 40. So our fifth term which again, we use the recursive technically to do it, is 40. This one's probably my favorite problem of them all. So the value of the third term is 12. The value of the fourth term is 21, okay? The big thing here, this sequence is arithmetic. So arithmetic means we either add or subtract. So it's always good to use out a table when you're given some information like this. So we know the third term, which is what I have written out in dark blue here, is 12. And then in dark green here, I have the fourth term is 21. So that's how I wrote it out. I know it's arithmetic, so how do I get from 12 to 21? Well, I add by 9. So from here, I actually can just do all the things that I've been doing. I know my start number is 12. I know my start time is 3. So when I write my explicit, because this time the explicit is first, we get f of x equals 12 plus 9 times x minus 3. My recursive goes f of x equals f of x plus 9, given f of 3 equals 12. And then lastly, it's asking us what the 10th term is, so we replace all the x's with 10. So tell me what you get. Should have gotten 75. So this is the end of the video. I know I talked really fast, but it was all review. You can always rewatch it. This is to help you so that you actually do your review, because your review packet is extra credit. And this video was worth 20 points. All right, let me know if you have any questions in class.